Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day to each and everyone. So this will be our first lecture for this final coverage. So as you can see here, this would be the our topic for week 8. But since suddenly they suggested, or they conveyed to us that um, our exam was on week 8. So I decided to make these topics as our topics for week 9 na lang. Okay, um, so this would be our first topic in our final exams. Okay, so and then as you can see um, on our midterm exam, I wasn't include these topics for our exams, since no as I have said, this would be included in our um, final coverage. Okay, so start tayo. So we have here an energy. Okay, our topic for these videos is or this season of our classes would be energy analysis for control of volume. Okay, so what would be these types of topics here, no? So um well, by no basically by giving you a brief analysis, okay, or brief discussion about this one. When you talk about energy analysis for control volume, it talks about the flows of mass, flows of mass, okay, with respect to a certain volume. Okay, so ibig sabihin nito, no, since nung sa first natin is first natin sa midterm natin na coverage is we are not actually considering about the kuan considering about the uh, flows of kuan, no, since no as we can observe on our previous topics, our mass is basically not flowing, okay, or not changing with respect to the kuan volume. So here we are concerning about those mass in which they are not constant with respect to the volume. Okay, so ibig sabihin nun, meron tayong flowing, meron tayong in of the mass, and then at the same time meron din tayong out of the mass. Okay, so yun, so we can say that, no, energy analysis for a control volume. Okay, so as you can see here, no, before we tackling about those topics, no, we have here the conservation of mass and control volume. Okay, we have to from this paragraph here, we have to differentiate about the conservation of mass and the control volume. Okay, kasi magkaiba kasi sila. Okay, so here, no, as you can see here, no, we have here a system or schematic diagram of a control volume showing a mass and energy transfer. Okay, so no, as you can see here, as I have said, we are talking about here a flowing of mass, but since we cannot actually have the flow of mass if there is no a change of energy, okay, or change of um, or transfer of energy. Okay, so that's why in here we are also talking about transfer of energy. Okay, so as you can see here, we have here different types of or different instrument, no, that is being used in this um, diagrams. We have here the steam expanding against piston accumulator initially evacuated, and then meron din tayong heat transfer. Okay, so this would be the um, an example of flowing of mass. Okay, at the same time, transfer of energy from one phase to another. Okay, so meron tayong equation dito. We have here a rate of change is equals to positive. Okay, if change is in, okay, ibig sabihin nun flowing into the system. Then it is negative if that is an outer or flowing out from the system. Okay, so then if meron tayong different types of, or if meron tayong if meron tayong mass, okay, that is flows in, okay, masses, no, kung meron tayong maraming mass or masses that is flows in and flows out to the system, no, we have to use this equation number 4.1. Okay, we have here um, the average of the mass that is conservative is equal to the summation of rate of mass, okay, that is entering minus the summation of rate of mass that is exit, no, or moving out. Okay, so meron tayong equation din dito. We have this mass of the conservative of volume, no, is equals to integral of rho dv. No, bakit rho dv? No, we know that since yung rho natin, or yung rho natin, where rho here is the density, mass density of the system or the fluid that is being flowing, okay, um, um, we manipulate that equation to get the conservation of mass. Okay, so we have here integral of rho dv, okay, where rho is mass density. Okay, then we know that that rho is equals to the inverse of weight density. No, we have here 1 over v, no, that is weight density yun siya, multiplied by dv, or we have here, no, we can also say that mass of A plus mass of B plus mass of C, or summation of the masses that is involving in this system. Okay, looking at this system. Okay, so yun. Um, so one example of moving of the mass is this one, no, this figure 4.3. Okay, so meron tayong valve here, meron tayong velocity that is velocity of the mass that is entering, okay, on this pipe. Okay, then meron din tayong flowing out of the fluid. Okay, so as you can see here, no, since we are always talking about the kuan, no, most probably kasi lahat ng mga calculation natin sa kuan, lahat ng mga calculation natin um, sa topics na to is most concerning about those neglecting the frictions. Okay, so that's why in here, no, neglecting the friction that is being that can oppose, no, that can oppose the flowing of the fluid here sa figure 4.3 natin. Ang mangyayari sa velocity natin, okay, or the mass flow rate ng fluid natin is equal to the volume times the is equals to the velocity times the area. Okay, or we have here, no, pag multiply mo yung velocity times area, ang mangyayari is volume density, volume rate na yun siya. Okay, so magiging meter cube per second. So that's why in here ang formula natin for volume flow rate is velocity times the area. Okay, so yun. So okay, so tingnan na lang natin siya. Pakibasa na lang din tong example number 1. Okay, so yun. Okay, now the energy equation for control volume. No? So this equation here na E energy 2 minus energy 1 is equals to transfer of heat from state 1 to state 2 minus the transfer of energy from or the work from state 1 to state 2, okay, yan actually yung ginagamit natin na energy equation, no, alam natin yun siya, yan yung ginagamit natin na energy equation doon sa previous natin na topics, but we have to manipulate that one, no, since we have here, no, in this equation kasi, no, hindi diyan na include yung movement of or the energy that is being used by the moving fluid. Okay, so and the energy that is being converted. So that's why in here sa equation number 4.4, we have to derive some expression in which including those change of transfer of energy and the change of mass we have here um, derivative of conservation of energy with respect to time is equals to the rate of flow of heat minus the rate of change of work. Okay, so yun. Okay, so pakitandaan na lang itong equation na yun. Okay, at the same time itong equation na energy is equals to where energy here is internal energy plus 1 half v squared plus gz, no, that is actually the unit. Okay, unit energy. Okay, kasi divide natin yun siya ng mass para mawala yung mass doon sa 1 half mv squared natin, so para maging 1 half v squared na lang, at saka yung sa mgz natin, so nawala yung mass, so naging jz na lang. Okay, so yun. So okay, so as we can see here, the energy, okay, the energy equation, okay, or the rate of change of energy is actually equal to the force times the velocity of the changing fluid. Okay, so equating those equations natin sa taas at saka itong energy equation natin na nanggaling sa kuan natin dito. Okay, we have here E plus PV is equals to U plus PV plus 1 half V squared plus GZ, and we know we introduce a variables, or we introduce a no, specification that is involving here in thermodynamics. We call that one as a enthalpy, no. Enthalpy is H, which is equal to internal energy plus PV, no. Na-introduce na natin yun siya actually sa previous natin na topic. So therefore equal siya sa H plus 1 half V squared plus JZ. Okay, okay, so we have this total energy equation, okay, A plus PV for changing of volume. Okay, so yun, so pakibasa na lang din example number 2 na yan, so madali lang din naman yun siya. Okay, so therefore taking the derivative of the total energy equation, no, we have here equation 4.4 becomes, itong equation 4.4 natin dito, ito siya, becomes this. Okay, becomes this equation here, no, total. Meron tayong mass flow rate times the energy, no, na-involve. Meron din tayong entering yun siya at saka exit. Meron din tayong change of energy that is flowing in at saka change of energy that is flowing out minus. Okay, so nandyan na lahat actually, no. Ito yung pinaka-important na equation natin. Okay, itong equation dito. Okay, so yun. Okay, taking out the parameters that is entering and exit, no, or flowing out, so meron tayong equal or total equation here dito sa baba. Okay, ito na yun siya. As you can see here, we separate here the quantity that is due to entering of the fluid, and then the due to the flowing out of the fluid. Okay, so yun. Okay, so if this summation here is actually due to, since may mga system naman kasi tayo na um, involving many flowing in of the mass, no, so ibig sabihin nun marami siyang entering spot where the mass of where external mass can flow in to the system. Okay, so we have to take the summation, okay, of that entering quantity of fluid. Okay, so that's why in here derivative of energy conservation is equals to, okay, ito yung equation na to dito, na equation 4.7. Okay, so but take note here that take note this kuan here, no, itong equation na to, kasi minsan yung enthalpy kasi is minsan nag-iiba yan sila. Okay, so pakibasa na lang din to siya actually, no. Madali lang yun siyang, meron tayong stagnation enthalpy kasi at saka total enthalpy. Okay, when you say stagnation enthalpy used in the fluids mechanics yun siya. Okay, so yung total enthalpy yan yung minsan na ginagamit natin. Okay, so yun. Okay, so if you have any question about these topics, ask it to me right before the exams. Okay, since malapit na naman actually yung final exams natin. And then kindly answer the koan, no? The provided exercises, no? Dito sa modules natin, and then submit it to me kasi that will be recorded. Okay? So that will be recorded. Okay. So once again, if you have any question, you may just ask it to me. So assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.